Hello and welcome to one of our first 3D design tutorials. Today we're going to be using a very simple and easy to use tool called Tinkercad. Tinkercad is web-based, so you run it in your browser and it allows us to manipulate and build with shapes and get rough builds out without a lot of shape manipulation. So with all that, let's get started. You can see here that I am on the Tinkercad website. I've logged in with the team login. You will need to use this for any of our designs so that we have a repository of anything that we want to come back and grab, we can. You can see that I have already supplied the team with a template for the pulley. Now this is just a solid core file that has the ability to mount up to our pulleys and our wheels. What we're going to try to do today is allow us to insert a nut and pass through a 1/2 inch piece of all thread. This will be good for powering our intake and powering our shooter. So with that, we're going to start by, we don't want to corrupt our pulley template, so what we want to do is make a duplicate. So we're going to click on the gear in the top right hand corner and say duplicate or duplicate, depending on the tense of the verb. You'll see that it takes us to our workspace. The controls are very easy in our workspace to manipulate the piece. If you need to select something, it's left and drag. You can see that allows us to select it. Holding down the right click allows us to warp and change our frame of reference around the camera. Middle mouse button allows us to zoom in and out by scrolling forward and backwards. So the very first thing we need to do is we need to add a 1/2 inch hole to the center of this, which will allow us to pass through a 1/2 inch piece of rebar. Working with Tinkercad is in millimeters, metric units, so we're going to need to take and convert our SA units to metric. The easiest way I found to do this is just open up a Google search and type in inches to millimeters. It'll give us a conversion unit here, and you can see that I've typed in 1/2, and that tells us that it's 12.7 millimeters. So to simulate the all thread, we're going to grab a cylinder hole. If it's gray with the lines passing through it, that means it's a hole. And I'm going to take and just stretch it out real long. And it needs to be 12.7 by 12.7 because it's round, right? We don't want anything oblong. So 12.7, 12.7, and there we go. Now we have an exact 1/2 inch hole that we can insert to the middle of our piece. And that's all great, but 3D printing is not super exact, especially when you're doing high amounts of extrusion. The plastic tends to creep and kind of get in the way of things. So what we're going to do is we're going to add 3/10 of a millimeter to make this 13 by 13. And that'll handle any kind of thermal contraction or thermal expansion that we may have in the imperfection of our print. So with that, the next thing we need to do is we need to add our nut. Nuts are hexagons. So we're going to reach over here to our pieces and we're going to look for a hexagon. We got squiggle, there it is, hexagon. So we're going to drop a hexagon. Now, the way that you measure nuts is that they're measured across from the flat to the flat. you can see here that our flat to flat currently is 17.32. Now, I went to the hardware store and bought a nut that'll fit a piece of 1/2 inch, and its flat to flat is 3/4 of an inch. So we're going to come over here to our inches to millimeters, and we're going to type in 3/4, 3/4. And we see that that's 1905. So hold it. If we type in 1905, it's going to warp the pristine shape of our piece, 1905. You can see that if I do that, it automatically moves the left to right, but it did not form the up and down. So now our nut is longer than it is tall. We don't want that, so I'm going to hit Control Z. Anytime you make a mistake, you can hold down the Control key on your keyboard and press Z, and that will back it up. You can also use the undo arrow up here at the top, which tells you to use Control Z with your keyboard if you don't want to use your mouse. So now that you can see, we're back to the 17.32 by 20. The easiest way that I have found to make this work is to hold down the Shift key on your keyboard and drag. And you can see that as you start to drag, it changes both the Z and the Y axis. Well, we need to go to 1905. There we are, 1905 by 22. But this is a solid piece, not a hole. Luckily, we can reach up here to our hole object, click on it, and make it a hole. Now finally, the last step we have to do is we have to figure out how far off the bottom we want to come with our hole so that the nut will fit into it, but not recess so much that it sinks and doesn't make contact with an outside nut that we're going to use to lock it. So in this case, we're going to take the height of the nut, which is 1/2 inch, (12.7), and in this particular case, we're actually going to go down. So we're going to say 11. We're going to subtract 1 millimeter from it so that it can make contact with the nut outside of the piece. So 11.7. And then, just to be safe, I'm going to go ahead and round that 7 down, and we're going to call it 11.0. So I'm going to reach over here in our height of our piece, and I'm going to raise it up 11 millimeters. Okay? So now that says that the nut's bottom will touch at 11 millimeters off the piece. But we need to take into account the height of the piece, which is 25. So 25 minus 11 is actually 14, so we need to go ahead and raise it 3 more millimeters. Now we're sinking 11 millimeters down, and that leaves us 14 millimeters free. Okay, now that we've got our two holes, we need to combine them into one piece to then attach to our template. To do that, you're going to simply hold down the Shift key, click the first one, click the second one, and now you can see both are selected. To combine them into one piece, we need to align them in the same plane. To do that, you can either press the L key or you can reach up here and click the Align button. You can see now that it gives us a grid that we're going to align on. So I want the middles. So I'm going to pick the middle here on the Z-axis and the middle on the X-axis. And now you can see that we have a perfectly combined object that we now need to make solid so we can move it. So the final step is to reach up here to the group button and either press Ctrl G or click on group. And now you can see we have a perfect object that allows us to move it as one piece and not two separate pieces. Okay. The final step that we need to do is we need to take our whole object that we just created and combine it with our template. Click on the first one, click on the second one while holding the Shift key, selects them both. We're going to align using the L or the align button. Center on the X, center on the Y. We can see that we have a hole here. We can see that our hole is roughly hexagonal shape and it's in the center. The final step that we need to do is select them both and group. And now you have a completed part. If you're ready to print this part, all you have to do is reach up and hit Export, STL, give it a name. In this particular case, I'm going to call it 1/2 inch or 0.5 pulley, and click Save. I think I'm going to change it to 1/2 pulley and hit Save, and that saves it out. To make this easier to recognize in the future, you can reach up here to where it says Copy of Pulley Template, click on it to change its name, and I'm just going to call it the same thing, 1/2 inch pulley. And with that, you have a completed object. I hope this helps. If you have any questions, feel free to contact me. Thank you.